The calorific value is the amount of heat released. Okay, nampak? The amount of heat released on complete combustion. And the standard of the fuel, how much amount that the fuel can supply. How much amount of heat that the fuel can supply. Okay. Amount of heat released on complete combustion of 1 kg of solid fuel at the reference state. Reference state here means temperature 25 degrees C, pressure 1 atm. Okay, this one common things lah. If at STP, family kan? STP, standard temperature and pressure. Okay, when a fuel is burned in oxygen saturated with water vapor, means ada moisture dalam dia punya fuel tu. Okay, the quantity of heat release is known as the high heating value, HHV, or gross calorific value. When the latent heat of water vapor is subtracted, then you get LHV, low heating value, or net calorific value, NCV. Okay, so basically if the fuel ada moisture, we burn it, then dia punya heat release is gross value because dia sekali dengan water, heat of water. But when we subtract heat of water, the remaining is the net calorific value. Okay. So for a hydrocarbon fuel containing C, H, and S, products of complete combustion, complete CO2, H2O, and SO2. Okay, this one if your fuel ada CHS. Okay, usually the term hydrocarbon means bila that component ada CH. That one is the main, carbon and hydrogen. So kalau the fuel ada S, then complete combustion react with the air, you akan dapat CO2 plus H2O and SO2. If no S, then SO2 won't be produced. So gas depends on the fuel that you have. Now at reference state of POC, product of combustion, at 25 degrees C, which H2O is in liquid form. We call that as GCV. The heating value is the gross calorific value. Okay, but at 100 degrees C, when the H2O at vapor phase, that one is NCV. Because when we heat the water, dia still akan keluarkan heat. Convert daripada liquid ke steam. So that heat tu, in between tu, kita subtract from the gross, then we get the NCV. Okay. Joule. Energy, joule. Ada unit joule, ada unit calorie. Energy. Okay, so basically GCV is larger than NCV. Okay, boleh faham. HHV, ada HHV and GCV. The same thing. This one, when you have H2O in a liquid phase. Okay, H2O in liquid phase. When we subtract the liquid phase, the H2O, we'll get LHV and NCV. H2O in vapor phase. Okay. Now, how CV can be determined experimentally using bomb calorimeter in the lab. They have specific equipment to identify the CV. Okay, so where 1 gram of coal is combusted at constant volume and rise in temperature is noted. So from there, can calculate the energy produced. Okay, theoretically, CV of coal can be determined from the heat of formation of the products. Complete combustion at 298 and 180 M. So in terms of the percentage of elements, these are the equations. Okay, this one to calculate GC in kilocal. Okay, the formula. This one standard formula. This one we call as Dulong formula. Dulong formula. Equation 10 is in kilojoule. So it depends on the unit that you choose to use. Okay, don't ask me how to derive this. I don't know how to derive this. Okay, they must start from something from the beginning on how to get up to this equation lah. Okay. Yes, correct. Okay, ini GCV. Then how to get NCV is GCV minus the heat of vaporization of water. Remember yang ni yang H2O liquid turn to vapor. This one NCV dalam unit kilocal. And then this one in unit kilojoule. Okay, all these equations applied with the assumptions that heat of formation of coal is 0. Okay, we assume HF for coal is 0. The coal contains H and O, therefore available H for combustion with gases oxygen become this one. Okay, this one the standard one lah. So if you have a sulfur, you can still use the equation. Okay, and the heat of vaporization is equals to this. This one in kilocal. In the thermodynamic table, you can see also in kilojoule. It also listed in the thermodynamic table. Okay, and this one, the CV of coal is the sum of CV of heat of formation of complete combustion. Sebab kalau incomplete, it will be different thing. Tahu tak beza complete and incomplete combustion? Hmm. Yes, correct. Hmm. 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 Kalau complete, dia let's say dia ada carbon, hydrogen plus the air. So kalau complete means C dengan H ni completely consumed. So dia akan jadi completely convert into this. Plus the energy. Okay, kalau incomplete, dia akan ada CO2 still ada, CO, sometimes dia still ada C, carbon. And then H2, H2O still ada. Okay, this one is incomplete. Okay. Okay, now we try to do the exercise. To use the equation. You snap dulu gambar equation. Ada tak? Ke ada dalam notes? Dah download notes. Hari.
Bring to front.
Yang equation ada? Equation. Kat slide tu okey tak? Okay, kita try buat exercise dulu. Guna equation Dulong's formula tu. It asks you to calculate the gross and net. So GCV and NCV, which analyzes C this much, H and O S. Okay, and moisture and also the ash. Okay, dekat equation tadi, M here stand for moisture. Okay. So try to calculate using the Dulong's formula. Lepas. Itu ada. Tapi yang ni dia bagi kilokal kan. Okay. Since tak ada value, ni guna equation ni kan? Yang ni? Ni kan? Kalau yang guna yang ni boleh, tapi since kita tak ada value on the head of vaporization, so you guna this one. But 30 something. Dapat value dia? Dia ada. Ni lebih kurang. Okay. So from here, we can see that GCV higher than NCV. Okay. Okay, now second question. It gives you the proximate analysis. Proximate. Okay, so we know moisture, VM, volatile matter, fixed carbon, ash, and sulfur. Okay, gross calorific value given is this. It asks you to calculate the proximate analysis. Okay. Ingat lagi tak apa proximate analysis? Consists of moisture. Kan? Moisture, VM, fixed carbon, ash. Kan? Okay. Sulfur include tak? Dalam proximate. Ultimate kan? Sebab sulfur dia element. So sulfur dalam ultimate analysis. Okay, so sini dia dah bagi the percentage. Okay, 2.4, 9.4, 58 and 9.7. Total 100% tak? Saya kira. Okay, so means that it includes the sulfur over here. Okay, Nirman, here we include sulfur 0.5 to make it 100%. Okay, but by right, the four main element only lah, approximate. Okay. Now the question asks you to calculate the moisture-free basis, means dry basis, dB. Okay, still remember how to calculate. So you need to recalculate everything to dry basis. Without moisture, moisture 0. Okay, it over 100 minus the moisture. Then multiply 100%. Betul? Okay. Basis, set basis. Basis kita 100 gram. 100 gram. Yes. Correct. Saya lupa nak mention basis 100 gram. So this one dalam weight lah. Sorry, yang tu untuk elemental. Kalau approximate, kita just directly ambil the percent. Kita tak perlu letak basis untuk approximate. Weight percent. So total should be 100%. Okay, dapat tak? Later you compare your result. Nak cari fixed coverage. 98 bagi 100 tolak. Yang ini lukis-lukis berarti pada kami iaitu okay. Dapat semua? Moist. Okay, now try yang dry ash free basis. Dry ash free basis ini, this one, let's say VM. You boleh guna straight away from here ataupun sini lah. Let's say guna ambil dari sini, then VM 29.4 bahagi 100 tolak moisture plus the ash. Ash is 9.7. Then multiply 100%. Kalau ambil dari moist free basis ni, just tolak ash je lah. So let's say VM, faham? So 30.12 bahagi 100 tolak 9.9.
Dia akan menunjukkan yang sama.
Cuba try. Sama tak? Dapat? Sama So either value lah you can use. Kalau dalam calculator tu, you boleh set equation terus lah. Tahu macam mana set equation? Sekejap, saya tunjuk. Saya ada lagi calculator kat sini. Okay, kalau macam moisture free kan. Moisture free kita dah tahu pembawah dia sama. 100 tolak, ni berapa? Mana tadi? 100 tolak 3.4 kan. Okay, 97.6 tu pembawah dia kan. So untuk set equation, letak alpha A. Sekejap. Back balik. Open bracket dulu. Alpha A bahagi 97.6 darab 100. Okay, itu ni kan. Then tekan calculate A, letak first one tadi 29.4. Then untuk nak calculate the next, tekan calculate je. Calculate A, masukkan 58. Then equal. Straight away dapat. Nak input the next value, tekan calculate. Dapat. Ini ash tadi 9.7, nak cari yang moist free, equal. Terus dapat. Okay. Cepat sikit lah. Dia set equation. Similar step lah if you want to use for dry ash free. So ni bahagi, instead of 97.6, bahagi this thing lah. Dia dah fix kan. Then you just key in the info, the value for A. Okay. Okay. Sekejap.
Untuk pakai itu semua dalam satu ke yang tadi.
Kalau apa? Dry basis tu, pembawah dia semua sama kan? Just input the value of A. So kalau dry ash free, pembawah dia dah lain. Dan just edit dekat pembawah dia lah. Numerical belum ambil kan? Dalam numerical saya ajar guna calculator macam tu. Okay, boleh Okay, can we proceed number 3? Okay, for number 3, ultimate analysis of the coal given in dry basis. Okay, so dia ada C, H, N, O, S, and H. Moisture content 5%. Okay, the gross calorific value, GCV, is this on dry basis. Okay, this is on dry basis. So it asks you to calculate the GCV in moist basis. Okay, kita letak dalam table dulu. Arrange the element. Sorry. Okay, arrange all the element. Yang given one is dry basis. So arrange dalam dry basis. Total up semua must be 100%. Dry basis means exclude the moisture. Okay, now dia nak reverse. From dry nak to moist basis. Okay, we know that moisture content is 5%. So kita include the 5% first over there. Okay, tadi untuk dry basis, the X over 100 minus moisture kan, 100%. So now kita reverse. So X over 100 macam ni, sekejap. Salah. Ni dapat Y. Okay, now kita nak cari this X. So, Y over. And this one. Y ni adalah dry basis. Okay. Y ni dry basis. So kita reverse. Value X adalah moisture basis. Ini X, ini Y. Okay, cuba set equation. Divide 100 multiply 95 kan? 95. Okay, let's see bila dapat tak? A 77. Okay, then the next one just calculate, put the value. Ini baru cari percentage. Then only you can proceed to calculate the GCV guna Dulong's formula. Dapat. Around the ini dalam unit kilocal. Joule. Joule ini dapat. Berapa yang most basis ni? Okay lah, roughly dah.
Saya tak roll off beli
Okay. Yang dry basis ni?
NCB.
GCV lah, GCV.
Saya dapat 3,000.
Probably dah. Okay lah, in the range lah. So kalau beza sikit-sikit tu tak kisah sangat. As long as in the range. Okay. Okay, so we are done with chapter 1. Any question? Basically, chapter 1 basically pasal proximate analysis. I just recap lah. Proximate analysis, ultimate analysis. Okay. Just recap over here. Okay, so chapter 1, proximate analysis. You need to know what is it about. Dia ada moisture, VM, FC, ash, and some sulfur. Okay, and then the ultimate analysis. Ultimate analysis here, elemental analysis lah. For example, C, H, O, N, Cl, S, and others lah. Kalau ada. Usually, commonly dalam calculation is up to here. In our syllabus lah. Okay. And then, okay, the proximate analysis tadi, you must know the dry basis, calculation dry basis, then dry ash free. So yang tu juga. Okay, from ultimate analysis here, you must know how to generate the chemical formula. Chemical formula of the fuel. Okay, then the third one, today's lecture, which is the CV, calorific value. Where you have GCV and NCV. Okay, both these can be in moist basis, dry basis, dry ash free basis. This one using Dulong formula. Okay. Okay, chapter 1. Basically, later you try to practice the exercise. Okay, so I need to start chapter 1 a bit. Sorry, chapter 2. Okay, for chapter 2, you will know how to calculate the combustion equation. Okay, we start with the theoretical airflow calculation, where at the end of the class, you should be able to determine the stoic and actual airflow requirement for complete combustion. Okay, in this topic, we focus on complete combustion. In the following chapters, then only we will touch on incomplete. Okay. Now, why it is important? Keep bigger. Why it is important to know the amount of air? Because we need to know the minimum amount of air required for complete combustion. Minimum amount. So when we have that minimum amount, we can just supply that minimum amount of air for complete combustion. We don't need to supply excess of air. Kalau excess nanti you punya blower or compressor design will be different because your loading of air volume different kan. Okay, and no oxygen contains in the product. And starting analysis of many combustion system, okay, is important so that no other incomplete combustion product. So minimum for complete combustion. Now for a hydrocarbon fuel given by CH. Okay, basically CH. Amount of X, amount of Y of H. Okay, the stoic. Stoic here we always refer as what to say? Optimum, the minimum amount of air. Stoic. Sometimes when I say combustion equation at stoic means at theoretical air. Okay, so this is the general combustion equation. CH, the fuel. Okay, this one is the air. Sebelum ni biasa kita tengok fuel plus O2 je. Kan? So CO2 and water. Where this one is not exactly accurate. Sebab dalam air kita ada N2. So that's why dalam calculation ni kita involve the N2. Where N2 is 79%, O2 21%. Okay, this one is standard fixed value. Okay, then equals to X amount of CO2. Okay, why X amount? Because it depends to the carbon supply. Plus Y over 2 for H2O and 3.76A N2. Okay, this value is fixed. Okay, where A, okay, the A over here is X plus Y over 4. A kat sini. Okay, this A. This equation is valid if the fuel is CH only. Okay, kalau ada O, then different formula. Kalau ada N, different formula. Because it involves X and Y only. Boleh. Kalau yes.
Different.
Dia ada additional minus Z something. Okay. Nanti that one we will go through later. Ni untuk 2 elements dulu. Okay, let's say you ada CH4, methane. React dengan air. O2 3.76 N2 equals to CO2, XCO2 plus Y over 2 H2O. 3.76 A and 2. Okay, from here kita boleh cari A ni based on XY over here. So A kat sini is equivalent to 1 plus 4 bagi 4. 2. Kan? So 2 A replaced by 2. So CO2X ni replaced by 1. This one? Two kan? So this one is 2 lah. 4 over 2. This one replaced by 2 just now. So 3.76 multiplied by 2. Boleh? Okay, kita try. Yang tadi methane tu kan? Methane tadi dah. So ini dia punya final. 2. So ini dia punya final equation. You must mention this final equation at the end of your answer. Okay. Ini multiply lah. So akan ada value. Now try for butane. C4H10. A dia dapat apa? Yes, correct. 6.5. But yeah. Okay, so 4 CO2, 5 H2O plus ini this one berapa? 4 and 2. Okay, so this is the final combustion equation. Okay, meaning that 1 mole of butane hanya memerlukan 6.5 only. Minimum amount of air, 6.5 mole. Okay, so if you supply less than 6.5, combustion tu incomplete, correct? Kalau you supply 8, excess. So excess dekat produk akan ada oksigen. Sebab dia excess, terlebih air kan. Okay, boleh faham konsep? Okay, ni kalau ada O. Okay, bila O, we represent O as Z. So, stoic equation CHO. A sekarang dia involve the Z. Same thing lah. Try to calculate for methanol. generate the combustion equation. Okay, A dapat 1.5. Okay, now try for butanol. C4H9OH. So total H is 10. Okay. Okay, A6. Okay. Okay, I think up to there first lah. Sebab this one, it will need to proceed until the exercise, then only you understand. Okay, so we stop up to the stored combustion equation first. Okay. Okay, so hope you understand. If you have any question, just text me in Teams lah kalau masa you study kan. Tomorrow kita akan proceed with the air fuel ratio until we do some example on the final exam question. Okay, so that's all. Thank you.